Therefore, the final answer for this is obtained as 2 by root 5 sine inverse 2x minus 1 by root 5 plus c is what we obtain for the given question. Therefore, integral of 1 by root 1 plus x minus x squared dx is 2 by root 5 sine inverse 2x minus 1 by root 5 plus c using the complete square method. Now let's take a quick session on evaluation of integral this, because this is as similar as the previous two sessions we have taken on the complete square method. So when I have an integral of this where we do not have the denominator but the numerator, say for example I compare this with the example problem, I evaluate integral of root of x squared plus 2x plus 5. Now I compare this with this, and clearly I can make this a perfect square by taking common, and then this reduces to the form of this, and clearly this can be reduced into this form, and we know that integral root x squared plus a squared dx is half x root x squared plus a squared by 2 sine h inverse x by a plus c is what we substitute here, where a is 2 and x is x plus 1. So is how we do it, and then finally the simplification gives us the required answer. So this is as similar as the previous sessions. The ultimate destination is to make this a perfect square. Integration of root ax squared plus bx plus c dx is done using the complete square, and then using the formula this equals this. Now next is the evaluation of the integrals of the integral in the form px plus q by root of ax squared plus bx plus c dx. Now how do we evaluate which has the functions both in the numerator and the denominator is what we are going to see in the session. So in order to evaluate integral px plus q by root ax squared plus bx plus c, then the method is not by complete square, but we have a different method which we are going to see now. So let's take an example problem and try to understand solving integral of this type. So let's take an example problem and then understand the similar method of evaluating the general form of px plus q by root of ax squared plus bx plus c. So to start with an example problem out here, if I wanted to evaluate integral of x plus 1 by root of x squared plus 3x plus 12 of dx, then this is clearly in the form px plus q by root of ax squared plus bx plus c. And of course, where a, b, c and pq are real numbers. So in order to evaluate this integral, we have taken x plus 1 equals a into d by dx of x squared plus 3x plus 12, the one which is inside the root, that is ax squared plus bx plus c plus b. Now this is assumed as the formula. We have to take this as the formula and equation 1. So utilizing this, we have to solve the integrals of this type. So numerator is a into d by dx of the value inside the root of the denominator plus b is how we understand this step taken as a remembrance formula. So as I proceed with this, I clearly see that d by dx of x squared is 2x, d by dx of 3x is 3, and d by dx of a constant is 0 plus b. That implies 2ax plus 3a plus b is equal to x plus 1 is equal to this. And using this, the coefficient of x here is 2a and coefficient of x here is 1. So equating the like coefficients, we get the values of a and b. Ultimately, the destination out here is to find a and b. Therefore, I equate the like coefficients, and therefore 2a will be equal to 1 and 3a plus b equals 1. And then this reduces to a equals 1 by 2, and therefore substituting in the other equation, 3 times of a, which is 1 by 2, plus b is equal to 1, and therefore b is 1 minus 3 by 2, which is minus 1 by 2. Therefore a is 1 by 2 and b is minus 1 by 2. Now substituting these two values in equation 1, I get this to be replaced with a and b, and then we simplify. So let's see how we can simplify by substituting this in equation 1. Therefore, substitution in 1 gives us x plus 1 equals a, which is 1 by 2 times d by dx of x square plus 3x plus 12 plus b, which is minus half, is what we get out here. Now, as I see the left hand side, if I want to bring this into the question, I need root of 3x square plus 3x plus 12. Therefore, now here dividing by the term root of x squared plus 3x plus 12 and integrating over dx, let's see what happens. So initially I divide with this and then integrate over dx. I get this to be x plus 1 by root of x squared plus 3x plus 12, but integrated over dx, I get this. And the reason for dividing this and integrating over dx is that when I divide and integrate, I get back the original question. This is the integration I need to find, which indirectly gives me half integral d by dx of x squared plus 3x plus 12 by root of minus half integral 1 by root x squared plus 3x plus 12 of dx. Now this has to be further simplified and then substituted here. Now as I see here clearly, this is in the form f dash x by root fx, where we have integral f dash x by root fx is 2 root fx plus c. So using this formula, this reduces to f dash x by root fx, where f of x is x squared plus 3x plus 12, reduces to 2 root f of x, which is x squared plus 3x plus 12. Then I have 2 cancelled, and finally I get this integral, which has to be simplified using the complete square form as we have taken in the previous session. So let's simplify this to get the complete answer for integral of x plus 1 by root of x squared plus 3x plus 12 dx. Now as we got simplified answer as integral of this is root of x squared plus 3x plus 12 minus 1 by 2 integral 1 by x square of dx. Now I just simplified this and substitute. So let's see how we can calculate the considered part. Using the complete square method. Now this is in the form a square plus 2ab. Now this is in the form a square plus 2ab plus b square and minus b square plus 2l is what we get when I complete through the complete square form. And this, on further simplification, gives us a square plus 2ab plus b square, which is a plus b whole square minus 9 by 4 plus 12, which on LCM gives us integral dx by x plus 3 by 2 whole square, 12 fours 48 minus 9, (39 by 4). 12 fours 48 and 48 minus 9 is 39, which is nothing but integral dx x plus 3 by 2 whole square minus root 39 by 2 whole square. So this is in the form 1 by x square minus a square, which is nothing but integral (1 by 2a) log mod x minus a by x plus a plus c. So this reduces to 1 by 2a log mod x minus a by x plus a. So this would be further simplified by taking 2 cancelled, and this will be 1 by root 39 log mod 2x plus 3 minus root 39 plus root 39, which is substituted in this, and then we get the final answer, which is nothing but root of x square plus 3x plus 2l minus half times root 39 of log mod 2x plus 3 minus root 39 by 2x plus 3 plus root 39 plus c. So integration of px plus q by root ax square plus bx plus c is done using a into d by dx of denominator plus b times plus b, which gives us the complete answer. The method as applied here applies for any problem which has the function in this type. Next is evaluation of the integral of the form plus this dx. If I have a problem which is evaluated in this form, let's see how we can evaluate an integral of this type. So in this case, let's take an example problem of integral 2x plus 3 by x square minus 5x plus 6 dx. Now clearly this is in the form of px plus q by x squared plus bx plus c. So this can be integrated using the process numerator is equal to a into d by dx of denominator plus b is the formula which I apply for evaluating any integral of this type, where nr stands for numerator, dr stands for denominator. So numerator is always taken as a times d by dx of denominator plus b, which on simplification gives numerator, which is 2x plus 3, and a times of d by dx of denominator plus b, which is equation 1. This on further simplification gives a times d by dx of x square as 2x and d by dx of 5x is 5 plus 0 plus b, which on further simplification gives 2ax plus b minus 5a, or minus 5a plus b, which we get in this form. That implies 2x plus 3 is equal to this, which when equating the like coefficients, I get coefficient of x here is equal to coefficient of x here, and the constant is equal to constant. I get 2a equals 2 and minus 5a plus b is equal to 3 is what we get. That implies here my a is equal to 1 and minus 5a plus b is 3, which is substituted in place of a out here. So this becomes b equals 3 plus 5, which is 8. Therefore a equal to 1 and b is equal to 8. So when I substitute this in 1, I get this in the form of this d by dx and the constant. So therefore my value of a is 1 and b is equal to 8, which is substituted in equation 1, then we get 2x plus 3 is equal to a times d by dx of this plus b is what we get when we simplify. Now I divide by this on both sides and integrate over dx. So dividing by this and integrating over dx, I get integral of 2x plus 3 by this, which leads to integral of d by dx of x squared minus 5x by plus 6 whole by this dx plus 8 times integral 1 by this dx is what we get. Now as I compare here, I see that integral of f dash x by fx dx is log mod f of x plus c. So using log mod fx, this reduces to f dash x by fx, which is log mod x squared minus 5x plus 6 plus 8 integral 1 by this dx. Now it is now the task of integrating this using the complete square form and then substituting in the whole of the integral, and then we get the complete answer. So this can be done using the previous case of complete square method and then substituting that integration as we have done in the previous case, we get the answer which is integral of the required question. Next, we have integration of the type evaluation of integral px plus q times root of ax square plus bx plus c dx. So when I want to evaluate integral of this type, let's see how I can do that. So evaluation of integral of this type, say for example, I take the example problem 3x minus 2 times root of 2x squared minus x minus 1 dx. Then let's see how we can integrate this. So in case of this, I take 3x minus 2, that is px plus q, equals a times d by dx of 2x squared minus x minus 1 plus b is what we get on this simplification. So we assume this to be a formula which we remember for integration of the type px plus q times root ax squared plus bx plus c. So this equals a times d by dx of something inside the root plus b. Next, simplifying this further, I get a times d by dx of 2x squared is 4x minus 1 minus 0 plus b, which gives me 4ax plus minus a plus b is what we get. Now, equating the like coefficients, I get 4a equals 3 and minus a plus b equals minus 2. That implies my a is equal to 3 by 4 and my b minus of 3 by 4 plus b equals minus 2. That implies b as 3 by 4 minus 2, which on LCM gives 3 minus 8 by 4, which is minus 4. Therefore, a equals 3 by 4 and b equals minus 5 by 4, which I am going to substitute here and simplify. Therefore, substituting in 1, we get 3x minus 2 is a times d by dx of 2x squared minus x plus 1 plus b, which is minus 4, is what we get when you substitute in terms of a and b into the equation. Now, multiplying both sides with root of 2x squared minus x plus 1 and integrating over dx, we get this to be integral of 3x minus 2 root of 2x square minus x plus 1 dx is equal to 3 by 4 integral d by dx of 2x squared this times root of this dx minus 5 by 4 integral root of 2x square minus x plus 1 dx, which is multiplied to each of the terms of equation 1, is what we get. Now we have a formula which can be simplified for this integral, which is done using the formula integral f dash x into f power nx dx is plus c, or this is f of x whole power n plus 1 by n plus 1 plus c. So using this formula, I can reduce this into the form taken here, 3 by 4 integral d by dx under root taken as 1 by 2 dx minus this, which comes same. This is in the form f dash x into fx whole power n, that is, this is simplified using the formula fx whole power n plus 1 by n plus 1. So your f of x is this, therefore 2x squared minus x plus this by n plus 1 by n plus 1 minus 5 by 4 integral of root 2x squared minus x plus 1 dx is what we get. So this is n plus 1 by n plus 1, which comes like this. And this is simplified using the complete squared method, where I reduced to the formula form integral root x squared plus a squared, or integral root x squared minus a squared, where I simplify using this respective formulae after converting this into the complete square form. And this is directly with the formula which we have in this form. So simplifying this by using complete square sum and writing them together is the final answer for the question which demands for integral of this root of this dx in the form px plus q root ax squared plus bx plus c. Integration connected with complete square form.